One big thing before we get into today's notes. I told you guys your first quiz was next Thursday, the 28th. All right, so you guys that weren't here yesterday, our first quiz, Thursday, October 28th. Now, thinking about that yesterday, that's a whole bunch of time and a whole lot of material before our first quiz. 1, 2, 3, 4, 5, 6, 7 days of new material, and then all of a sudden I'm going to pop a quiz at you. I don't know how successful we're going to be at that. All right. So what I'm going to do instead is starting tomorrow, we're going to have a quick pop quiz. All right. Yeah, I'm calling a pop and I'm telling you about it. Go figure. All right. So tomorrow it'll cover what we did yesterday and today, like 2 questions. You'll have 10 minutes to take it. It'll be like 7, 8 points. Okay. I think that'll help you guys. And we'll have a couple of those before next Thursday's big quiz. All right. So help you boost your grade a little bit, hopefully. And also start, you guys start remembering what we've done in the past. All right. Because I'm not too comfortable giving you that test on that Thursday of next week. And then that's it. All right. So starting tomorrow, basically tomorrow will be like, all right, draw me an angle of 400 degrees. Here's a graph, draw me an angle of 400. Okay. So starting tomorrow, quick pop quiz at the beginning of class that covers the previous day or two's material. All right, good with that? And you only get 10 minutes. All right, I can't give any longer than that. Good deal? All good? Okay, so what I need you to do right now, let's see, what did yesterday's notes? Well, actually, you guys have line paper too that you did the book work in, so if you want to go to that, all right, on page 4 or 5, draw yourself a nice big XY axis for me. And you guys, at least that were here yesterday, or if you watched the video, if you weren't here, draw me an angle of 120, please. 120 degrees. Draw me a correct angle of 120. Let's make sure we can do that. This will be part of the pop quiz tomorrow, but might not be 120, might be a little bigger than 120. So your best ability, draw me an angle of 120. Good job at you guys that were here. Nice work. Make sure you put your arrow in. Don't forget it. I don't know. Some of you guys are doing a nice angle of 120, but you're not telling me where your angle's going, right? Is it going clockwise or counterclockwise? Got to draw your arrow in, remember. Draw your arrow in. And some of you guys just need to watch the video. Okay, first side is always the initial side we called yesterday. That's always on the x-axis. All right, I'm doing this real quick, but again, you guys that weren't here, you got to pop in the video. We got 0, 90, 180, 270, and then back to 360. So 120 would be between 90 and 180, so everyone should have their second side in quadrant 2. Where was it? Closer to 90 or 180? Closer to 90. What do I call this side that I draw in one of the quadrants? Terminal side. Yes, that's my terminal side. And I need a rotational arrow. All right, so there's 120. All right, keep right there for me, please. Keep right there, because I'm going to introduce what I'm going to do today, which is called a, and this is in your notes, but I want to just do it right now on this diagram, reference angle. Today, I'm just going to have you guys find them, and then we're going to start using them over this next week. Here's what I want. I gave everybody a colored pencil. Everyone should have a colored pencil in front of them. Here's what I want you to do. Highlight the other side of the x-axis now. Okay, remember you see where your initial side is, right? Everyone sees that? Highlight the other side with your colored pencil. I'll do the same up here with my highlighter. So highlight the other side of the x-axis and the terminal side. Highlight the other side of the x-axis and the terminal side right now. Do you see that angle that you made right there? By highlighting the other side of the x-axis and the terminal side. That is the reference angle for 120 degrees. All right, this is what we're going to refer to as an angle's reference angle. It is the other side of the x-axis and the terminal side. X-axis, always the x. Keep that in mind. Always the other side of the x-axis and the terminal side. Now here's my, do you have a question? I don't want to know what it is.
Yeah, I do. Wouldn't this be an acute angle?
It's always acute. Yes, a reference angle is always acute. Okay? Which means what?
Which means the other side.
What's acute mean?
Less than 90.
So your reference angle always should be less than 90, correct? Anybody think you can find how big that angle is? That reference angle, you just highlighted it with a colored pencil. Do you think you can find the degree measure of it? Because that's what we're going to do today. What's up, Frank?
You take the initial angle that you had, and then you take 180, subtract the original angle from it.
All right, so what do I get for my reference angle?
You get 60.
60 degrees, which less than 90, everybody?
Yes.
That's acute. Yep, so there you go. That's what we're going to do today. I'm going to give you an angle. You find its reference angle. All right, and then yes, I know that's all I'm going to have you do is find it, but we're actually going to, a reference angle in this unit is huge. So I need you to have the ability to find it. All right, but again, before we move on, reference angle formed by the other side of always the x. Don't use the y. Always formed by the other side of the x-axis and the terminal side of the angle I give you. And it always has to be less than 90. And positive, I should say that too. Less than 90 and positive. Okay, so that's what an angle's reference angle is going to be. All right, let's tackle a couple here. I think that activity was a little better than trying to describe this crazy diagram I have here. All right, for each of these angles, now you see beta, that's another Greek symbol. Remember sigma last unit? Beta is a Greek symbol. That's the Greek symbol right here, beta. It's the angle. That's what I'm talking about. It's the angle measure. Right? We're going to draw a diagram just like we did yesterday, and then you guys are going to help me find its reference angle. So I have an angle of 160 right now. All right, so just draw the 160 for me. This is practice from yesterday. Draw 160 for me. So everyone's got 160 going. Hopefully you're drawing the terminal side where? Closer to 90 or 180? 180, good. We're getting good at this. Still need your rotational arrow. If you want, grab your colored pencil right now. See if you can highlight the reference angle with your colored pencil. The XX, the remaining x-axis, and the terminal side. There's your reference angle. I'm putting mine in yellow. If you guys have highlighters or don't care for my colored pencil, go right ahead, use what you want. So there's the reference angle. All right, now here's the part today. Do you know how many degrees is it? Can you find how many degrees are in that reference angle? And it's got to be less than 90 and positive. Any takers? Because I'll start calling out people after. Elizabeth,
20.
How'd you get 20?
180 minus 160.
180 minus 160. There we go. And then just how we're going to label it in this problem anyway, we'll say beta with the little r for reference angle is 20 degrees. Yep. So your reference angle is 20. All right, these last two examples we've stayed in quadrant 2. Let's try to get out of quadrant 2 now. All right, let's get out of quadrant 2. Ready? So let's look at 300 degrees. You guys that were here yesterday, 300, what quadrant am I in? Quadrant 4, right? All right, so let's see what that angle looks like. Is 300 closer to 270 or 360?
270.
Or 360, which one?
270.
270, yep. So get it closer to 270. Now it changes a little bit. Now it's going to change a little bit. So here's our angle, right? Now I got to figure out where my reference angle is. Now, if you guys pick the other side of the x-axis and the terminal side right here, that's going to be bigger than 90. Everyone see that? That's not my reference angle. All right, because that's bigger than 90. That can't be my reference angle, but I still need the x-axis. It's the x-axis and the terminal side that gives you an acute angle. Do we see where it is in this case? No? Okay, that's fine. Well, I can't do this with the x-axis and the terminal side because I can see that's bigger than 90. So what's the other choice I have with the x-axis and the terminal side? This acute angle right here. What's this? That's my reference angle right there. Here it is. It's got to be formed by the x-axis and the terminal side that gives me an angle less than 90. Never the y-axis. I always go x-axis. All right, now the question is how many degrees in that angle and how can I find it? How can we find that reference angle? How many degrees in that angle right there? Any thoughts, takers? What's up, Sarah?
360.
Okay, yep, look. If I'm trying to find how many degrees in this angle here, right? Don't both of them to all of it together. I go all the way around for 360. Yeah. So 360 minus 300, the actual angle gives me a reference angle of, I was going to write 30 for some reason, 60 degrees. I didn't give you guys much room, sorry. Less than 90? Yep. So there's my reference angle. Questions? Yes, go, Elizabeth.
When it's like not in the first or second quadrant, is it like if it's in like the third or fourth, is the reference angle always going to be just the same angle?
What do you mean the same angle?
Like the reference angle is on top of that angle. Like
Well, let's check it out. Well, yeah, in the fourth quadrant, yeah.
Okay.
We haven't done one in the third, but we are right now at 210. So let's check that out. Let's check out 210. Two tens in the third. I just gave that away. Anybody where in the third? 180 or 270?
180.
180, yeah. So here's my angle right there. Okay, everybody highlight the reference angle now. Where's the reference angle in quadrant 3? Highlight it. Is it the case that I do the other side of the x-axis and the terminal side? Yep, there it is. You should never be highlighting the y-axis. Remember, the reference angle is always the x-axis and the terminal side. Ooh, this always gives kids problems, how to find that angle. Reference angle in the third quadrant. How do I find that angle? Remember, the original angle was 210, so you definitely want to do something with the 210 I just graphed.
Maybe 210 minus 180.
Well, yeah, what's this right here? This is 180, right, everyone? That's 180. And I just went 210. So if I want to find what's remaining, yes, I do 210 minus 180. 210 minus 180. And what do we end up with? 30 degrees, yep. So 2, quadrant 4, quadrant 3, the only one we haven't tried yet. What if an angle is in?
1.
Quadrant 1, okay. 78 degrees. Anybody?
78.
78?
Mhm.
If an angle's in the first quadrant, it's its own reference angle, right? Because there's no, because look, hey, take a look. If I go this side of the x-axis and this terminal side, what's the problem?
More than 90.
That's way more than 90, so that can't be a reference angle. So the only way I can do it is highlight the same angle I just did. Yeah. So the reference angle, beta r here, is 78 degrees. If an angle's in the first quadrant, it's its own reference angle. Questions? Jeremy.
Why can't you do 12, the 12 degrees?
Why 12? But here's the problem though. What are you now highlighting, Jeremy? You're highlighting this angle. Where's this? What axis is this on? That's y, isn't it? The reference angle is always x-axis and the terminal side. Okay, never the y. You should never be involving the y-axis. Okay, any questions about the 4 quadrants? What do I need to do in the 4 quadrants? Now look, I'll give you this. If you want to use it, fine. But I think most of you could just look at the diagram and find the reference angle by yourself. But if you want rules to find the reference angle, if you're in quadrant 2, you do 180 minus the angle you're graphing. That's what we did here. If you're in the 3rd quadrant, you do angle minus 180. The angle you're graphing minus 180. If you're in the 4th quadrant, you do 360 minus the angle you're graphing. And we just talked, if you're in the first, it's its own reference angle. If you want to remember those rules, that's fine. But honestly, I think most of you are capable of looking at your diagram and finding the reference angle. Okay, we talked basic angles and basic quadrants. Now I want to just go to the different types of negative and bigger angles that we talked yesterday too. Okay, negative 110. I saw a lot of you guys yesterday when you're doing your delta math. You don't like to deal with negative angles, and I don't blame you. How can I make that into a positive one? Negative 110, what do I do with it from yesterday? Make it into a positive angle between 0 and 360. Add 360, yep. So negative 110 is going to be the same as graphing what? 250, yep. Which makes me in quadrant 3, yep. So I graph my angle in quadrant 3. Closer to, I'm not even going to ask anymore, closer to 270. But what do I have to make sure of here? Actually, yeah, oh. Yeah, I'm good. Never mind. I just had a brain freeze. Happens. Where should my arrow be going now? Because remember, you weren't. I didn't ask you to graph 250. I have to ask you to graph negative 110. Where should I be going? Whoop, good. Making sure we're going clockwise, right? Because it is a negative angle.
Is it the same if you start from that way? Like you go minus 110 and then that way? It's the same.
Yep. All right, where's your reference angle? Right here? Now look, I can use 250 now to calculate the reference angle because the reference angle is always positive. Always positive. So if you want to use 250 to calculate it, go ahead. So how can I find that reference angle? If you want to use the rules I just gave you, which are up here, and they're a little bit off the chart. If you got an angle in the 3rd quadrant, you do 250 minus 180. So your reference angle, 250 minus 180. Your reference angle will be 70 degrees. I always like to use the positive version to find the reference angle. All right, let's smoke through the rest of these here because I want to give you time to practice. Negative 280, add 360. Is that everyone all right with that? Keep adding 360. What angle am I going to have you graph here? 80? Uh-oh.
Oh,
Where's 80? First quadrant. Oh, this is going to be a nice one, huh, guys? But just make sure your arrow's going clockwise, though. Make sure we got this going here. What do we know about an angle in the first quadrant? What's its reference angle? Itself, right? So what would it be, the reference angle here? 80 degrees. Boom. $605, what do you want to do with that? That's a little bit too big for me.
Subtract from 360.
Yes, darn right, Sarah. Keep subtracting 360 till I get one between 0 and 360. So subtract 360. What do you got there? 245. What quadrant you in? 245. 3. Oh boy, where's that one?
Closer to 270?
Is it?
Yes.
Yes, it is. I had to think if it was halfway or not.
Not quite.
Okay, you guys that were here yesterday, can you help me with the arrow? Because remember, it was 605, not 245, 605. First, clockwise or counterclockwise? Counter, because it's positive. Do I stop here?
No,
Nope, we keep going past 360, the old loop-de-loop. And there it is. But still use 245 when you calculate the reference angle. What do you have to do with the 245 to calculate your reference angle in the third quadrant?
subtract 180.
245 minus 180.
65.
And remember, always get out angles that are positive and less than 90. Because we got to do something with those reference angles in the next couple days. And the final one for reference angles anyway, negative 410, what do you want to do? Add 360. Uh-oh. Uh-oh.
keep adding.
Negative 50?
Keep adding 360.
Well, negative 50 though, right? Before you keep yelling at me? Negative 50? I don't like the negatives. Yep, keep adding 360. So I am going to end up graphing
290.
290.
Why would that be?
290. How about 310? One job. Why do I listen to anybody anyway? Just get my own notes out. What do we say it was again? 290? 210? All right.
310.
Okay, you can stop yelling. Everyone, their attitudes here. Look at me, I'm a senior. What quadrant am I in?
4.
4. Oh boy.
So 1.
That's 50 away. So it's probably closer to 270, I think, right?
Yeah.
310, 270, that's 40 away. And it's 50 away from 360, so yeah. What's the deal with the arrow here, smart kids? You want to correct me all the time. What's the deal with the arrow? Go back to my original degree measure. Clockwise or counterclockwise?
Clockwise.
Clockwise, but stop here.
They go.
It was negative 410, so I got to go past 360. Boom. How do I find the reference angle using my 310? 360 minus 310. 50-degree reference angle. How do you feel about these? Who asked the question yesterday about being on the line?
Sarah.
Sarah, you did? Okay, now let's talk about it. Because what if an angle is on the line? I told Sarah yesterday it's not considered in a quadrant. Okay, it's not considered in a quadrant, but I do want to give a name to it now. That's called a quadrantal angle if it's on the line. Quadrantal angle. And here's what I want to do with you. This should take a minute. You guys are going to rip off eight quadrantal angles for me right now. 2 of them have to be negative. More can be negative, but at least 2 have to be negative. A quadrantal angle is one that lands on the axes. It is not in a quadrant. All right, let's go. Rip them off. What do we got?
0.
0 degrees. Oh, that's clever.
90.
90.
180.
180.
270. 36.
Are we?
Oh, you need 8. Negative 90. Negative 180.
Learning my lesson for 7th period.
Negative 270.
450's on the line, right? You go past 360, 90 more degrees, you get 450. There you go. Quadrantal angle lands on the axes. All good? Okay, let's go. Let's plug out delta math. If you guys weren't here yesterday and didn't get the opportunity to do day 1, I'd do that first. You guys that were here, let's find some reference angles. I'll come around and work with you. Also, I gave you notebook paper. Pass your notes to work on the delta math 2.2 if you need to draw a diagram.